This is my first video update coming to you from Weizmann Research Institution, and we'll discuss a system design interview for programmers. This is a building in the Weizmann Institution of Science, the Nuclear Research. This is the Nuclear Research Department. So let's hope that nothing explodes here. Okay, so today's question would be design. Let's say you go to an interview and the interviewer tells you design a reservation parking system garage. By the way, as you see, this is my bikes. I came to here with the bikes from another city. And I'm not fit at all, which means riding a bike is easy. So please design a reservation parking system garage. So we'll follow the script that you should follow if you happen to be in a system design interview, and also in any programming interview questions. What you need to do is to basically follow the script, and the script would be step 1, clarify the question. Step 1 would be to clarify the requirements and the questions. By the end of this step, what we want to achieve is a state where we are able to actually describe the requirements, right? We want to be able to describe all the requirements and to clarify everything with the interviewer. Step 2, we would then come up with some basic design after we have clarified the requirements. Now that we have structured requirements, we can clarify the basic design. And then in step 3, we will discuss about how is this design extensible, can we support a higher load, etc. Interesting tree. Nice. They knew where to place the Nuclear Research Center for sure. Actually, I think it's also called the Canadian Nuclear Research Center, although it's not in Canada, definitely. If it was in Canada, it must be snow now, right now. Okay, so let's clarify the requirements. So let's remind the question: design a reservation parking system garage. Okay, so let's design. So the first question is, okay, the first assumptions. Can I assume that the user will come up? Here's a little kitten. Can I assume that the user will come with a mobile web application, or with and then he will use this application in order. He will use this application. Cats are smart. They are also interested in design. Okay. So basically, we need to design a reservation parking system. So we clarify the assumptions. Okay, so the user will come up with a web or a mobile application, and if the user comes with a web or mobile application, then he would need to contact its server. And what would he do there? He would ask to reserve a parking space. The parking space. Okay, so requirement number 1, we need to be able to reserve a parking slot and receive back probably a receipt. Step number 2, is it going to be also, so for sure he would need to pay for this parking slot, right? But can we use a third party to reserve? We don't want to design now a payment system. Okay, so let's clarify that we can use a third-party payment system. Next assumption is, because it's a parking slot, then how many parking slots are you going to have there? 2,000. So it's not a scalability issue. It's not a scalability kind of system design problem. So let's clarify this. Okay, next question. Is the payment the same for all slots? The answer was that no. We have three types of slots. One compact for small cars, another one is regular for medium-sized cars, and one large. So is the payment the same? No, it's different for all of them. For the larger, it's with the highest payment. But on different times it's the same. Okay, so we have all the capabilities that we need to implement. Reserve parking slot, pay for them third party, not high scale, we prefer consistency, and we have three types of payments: compact, regular, and large. Step number 2, basic design. So let's think about the APIs that we need to expose. So the public APIs would be reserve, to reserve parking slot. This is the point of the system, right? To reserve parking slot. The input would be the garage ID and the duration. And we would return the slot ID and the reservation ID. So users can now reserve. The second API would be the payment API. Let's call it /payment with a reservation ID, and now the user can pay and /cancel for canceling a reservation ID with an input of reservation ID. The internal endpoints that we want to have is the calculate payment with an input of reservation ID, the free spots to find, based on free spots, input vehicle type and garage ID, find me free spots. And also we can now clarify that smaller car can park on larger spots, but it would cost them more, so preferably the users would prefer to pay less. So only if there is non-existing smaller car spot, then they could use a higher one. The next internal API is to create an account if we want the users to be able to have a permanent slot, a repeating slot maybe, right? Okay. And scale is not an issue, right? Because it doesn't matter how many car slots you're going to have there. This is not a scaling issue. So we prefer consistency. So for that purpose, we would use some kind of an SQL database like a consistent garage. And step number 4 would be to design the database. For the database, we can use a table. We can design a few tables. Table 1 garage, table 2 reservation, table 3 slots, table 4 users, and table 5 vehicles. Table number 1, the garage. Table number 1, the garage, would have an ID of the garage, the zip code. We can later on partition by the zip code. The rate for a compact vehicle, the rate for a medium vehicle, and the rate for a high vehicle. Rate can be a fraction, so we can use a decimal. The reservation table would be the garage ID, the start time and the end time, and the slot ID that we have reserved, which is a foreign key. Also the garage ID is foreign key, and paid, whether he paid Boolean, true or false. The spots table would be an ID, a primary sequence ID, a garage ID, foreign key because the spot belongs to a garage, the vehicle type, whether it's small, medium or large, and the status, whether it has been already reserved or already been captured. The users and the vehicle tables could be for some permanent users. So the researcher needs to get back to doing the research. And step number 5 is going to be simply the flow. So in step number 1, we have clarified the requirements. In step number 2, we have built some kind of an API, public API, to reserve a slot, to cancel the slot, to pay for the slot. We have some internal APIs in order to calculate how much is it going to cost, whether, how much it's going to cost, etc. And as for the flow, which is this step number 5, We're going to have simply the web or mobile application which would contact the backend service. The backend service would contact an SQLDB, and we can have a single server, a monolith, stateless, few servers, doesn't really matter. This is again a low scale problem. So three main components: the client, which is web mobile, the backend server, and the SQL database. The SQL database, if we have many reads, usually let's discuss a little bit scalability if we need. If we need scalability, probably be on the read side, because users will do many more reads than writes. Check space, etc. So we could have some read replicas in order to solve this, and we could have some read replicas in order to solve this. And also for the payment, and we could have a load balancer in front of the database, right? We could have a load balancer in front of the database, because we have multiple read replicas, so the load balancer would balance the request to multiple read replicas. Also, we could have another component, which is the payment system, but as we said, we're going to have third-party payment system. So the extended system components are the web or mobile application, backend servers, SQLDB, read replicas, maybe multiple backend services, and payment system. We want to be strict, we want to be consistent in favor of availability, so everything is going to be consistent, databases are consistent, read before write, read lock, write, and that's it. Let's recap this. Design reservation parking system programming interview question. Step 1, clarify, we need to reserve. We need to pay for the system, we need to have consistency, we need to have different type of slots, compact, regular, and large. The API is going to be reserve slot with the garage and the duration, the payment and the cancel. Payment and cancel are going to receive an input the reservation ID. The internal endpoints are going to be calculate payment for reservation ID, the free slots, calculate them, allocate a slot, create account, and probably SSO and payment. This is not a scale issue. We had 5 tables: garage, reservation, slots, users and vehicles. Users and vehicles are optional in case we want to have permanent users and to remember them. The flow would be from web to backend to SQL database to a payment processor. And I think the thing that could most mix up people about this question is that in system design interview questions we expect to have some scalability issues, right? We expect to have some scalability issues. Questions, scalability related questions. And if we don't have them, then we can think maybe I'm missing something. But in this question, we are not missing anything. There is no scalability issue. This was it. System design interview question, design payment system.